Hello guys and welcome back. So I have the sim is done, so let's create a file read. Let's paste the path, let's copy this and let's preview the points. Okay, cool. Let's change this, set it to black, and let's play it, see how it looks like. And again, we don't have a lot of points, so we definitely need to increase this quite a bit. Cool, and then the attraction is happening, and now the colors are quite bright because we have to tweak them to account for that. So maybe 7, 8. Yeah, I think we can also animate the value. So let's say 6 here. Maybe 4. Yeah, 4 there, and then let's add a 4 here. Okay, let's do another preview because the velocity length changes over time. So you have to find a value and that works nicely and or animated. I think the swirly motion, I'd like to make it rotate faster for sure. And maybe increase the attraction. Let's hit play. No, I think the rotation is good. Cool, so let's do 1 frame, maybe here. I want to render that, so let's go up. This is the particle render, so let's just override this guy here. And go to this frame. Let's move the camera. Okay. Let's copy this parameter. Let's make it always on top. It is always on top. The point size is very, very small. So let's dive back in and copy this, the P scale. Let's hit render. And these are our points. Again, the rendering is just a preview for you guys to see how it looks like once rendered. And we definitely need to increase the point count a lot more for this type of effects. Okay, so the last bit I want to show is I want to add an extra thing to the sim and then move on to show some other stuff. So here, remember this global controller thing? We can increase the noise, and what I'm going to do is I'm going to add a transform node in here, just in the emission. I'm going to set it to 0 in the first frame and go to frame 6 and set it to 1. Let me first reduce the number of points to 1. Go to frame 6, set it to 1. And I'm also going to animate this 6 and maybe 12 in the beginning, and then 0 or 1, sorry. See? Yeah, so it expands and stops. And the beginning, see, it's very, very disturbed. but we have the original curve as well. Right now it's deformed, so we need to do two different versions, one for the force and one for the emission, and it's fine for now. I'm going to reuse the same thing. And we have to be a little bit careful because the velocity in these first frame can be very, very extreme, so we have to be mindful of that. But let's hit play and see how it looks. I wanted to add an opening or something like that for these guys, and it looks like the velocity is not getting inherited enough, so I'm gonna set this to 1, and that should give it some kind of splash in the beginning, and maybe also help with the circulation as well. And see, the points are now getting attracted as well. And there's also an inherent velocity here that will add even more velocity to the overall system, because these curves themselves they are rotating. So let's set this to 0.05. I only wanted the first force, see that first pop, to be there. And what we can do, we can also explore the curvature and how the animation, how this is going to show up. So we can do something like this instead. And here, let's do something like this. And let's increase the point count to 0.25. I just want to get a preview here, and let's preview it with this guy. Let's hit play. Cool. So we got a ring, we got some interesting splash or emission at the beginning, which we could use as well, using some isolation method, using the velocity to isolate that ring. See, we can isolate that ring and maybe use it as use it as a source to emit some trails from that, for example, like we did in the previous videos. Cool. So this is one way to open the portal, for example. Let's zoom in and play it, see how it looks. Well, depending on the camera, of course. Let's go back. Yeah, I want to cover the full thing. Let's set this to 10. And let's hit play. And of course, again, we can isolate that part and process it further to add some cool effects. We can also add another way in the sim. We can select or group these guys and treat them differently, or apply a custom force to them. Let's hit play. Yeah, definitely. I would like those guys to disappear or get deleted or fade away. They're gonna die. That's good. And the force is much stronger now as well, and we can animate that. And this goes into the timing and animation thing. We have a lot of controls here, and it's all up to you guys what you want to create. We have the speed. We can use that to convey that the portal, for example, is getting faster and faster. It's going to close, or something is going to happen to convey that there is a movement, there is behavior changes in there. So this is the result. Okay, that's one last thing I wanted to add, and now I want to show you guys the result. Did we preview this? Yes we did. Okay, so what we've done is we've added a curve ID and we've added a UV coordinate. So let me create a color node. Now I'm going to create a ramp from attribute, and this time I'm going to create a ramp from the UV coordinate. And it's giving me red because there is only a U coordinate at the moment, and that's the red channel. And Actually, we can do this. Let's create a proper float. Let's call this u. It's a float, and it's equal v at x. And now I can use the u coordinate only. And here I can give it a color. So for example, you see this is black to white. I can do this. I can change the color along the path of the curve. And give it something something unique, or control it in any way I want. Something like that. And as I hit play, those colors will get inherited. And this is something very, very powerful, because we can do this kind of stuff. We can track where the points are coming from, what curve they're coming from, and treat them differently. And this is one quick example to reuse that data, with just the u coordinate copied over the points. And this ticks over time. So if a point gets emitted here, its color is going to stay the same, because the UV coordinate that it did inherit does not change over time. Okay, I like this color, so let's create another point bob. And remember that curve ID thing we did? Come on. I'm going to create a new color, and let's connect, let's say random from attribute. I'm going to use the curve ID. And let's go back, and this is a random color based on the ID. If we hit play, see it gets kept over time. This type of coloration is almost impossible to do within the sim. You have to pre-process and prepare the data to do this in DOPS. So let's combine these two guys. I think a blend shape could do this, so I'm going to blend between the two, and I want to blend the color, and now I'm adding 50% of this plus 50% of this, and this is what I've got. We've got some very, very cool randomization. Now I can use can dive inside point fob, or let's copy this point fob. This is grading the color based on the velocity. I don't want to use a ramp. What I want to do is I'm going to create a color correct node, and I want to keep the color that is coming in the same, so it's the same color, but I want to use this ramp to change its gamma, for example. So the faster the particle, the brighter it's going to be. And the slower it is, the darker it's going to be. And so I can mix all of that. And again, this is just in SOPs here. As a post process, we're not changing this in. This is all happening afterwards. And these colors are actually very, very cool. Let's do a point replicate to increase the point count temporarily. I'm gonna set this to 10. Let's say we wanted 15 million, for example, on this. I'm gonna set it to a sphere, 0.1, and let's see how it looks. Okay, zoom in. It's still quite big. Let's say 0.25. And I'm going to stretch them by the velocity to get some streaks. Okay, and I'm also going to add some noise. Okay, and I want to, under the attribute inherit, I want to copy source attribute. This is gonna take, it's gonna take some time, but I think you guys got the idea. So let's render this. Let's copy this graph, or let's learn about new node. So in object merge, we can import sections of the graph. So I'm gonna use an object merge node, drag this path here, and now I have this input coming in. I can copy that node, go up to the render and simply use that instead. Okay, let's frame the camera. Let's zoom in. I want to see it close up. It's gonna take longer for it to send the render to Mantra, of course, because 15 million points will take longer to transfer to Mantra, and it's gonna take a few seconds for it to make that ready for rendering. Cool, I think the point size is quite big, so let's lower this 5 times. And let's hit render again. It's creating the arc tree for rendering. It's a part of the render. Cool, I think it's very small now. And it's taken longer to render, of course. And the more overlapping particles we have, the slower the render is going to be. I think the point count is very small. But yeah, I think you guys got the idea. We don't have to prepare everything in the sim. We have to think of ways to create interesting data that we know the particles will inherit, and then we can process those further and do stuff in SOPs here to add some more interesting details to the sim. Cool, I'll let this run and then we'll continue in the next video. Thank you guys for watching and see you in a bit.